Hello, beautiful people, and welcome. In this video, we are going to talk about the Pythagorean identity. Now, before we go ahead and jump into the identity, let's review a few things we've learned about trigonometry thus far. So the first thing we learned is about our eyeball, or our theta, our angle measure. Now, if we put our triangle onto the Cartesian plane, we put it on the initial ray, which is going to be our positive x-axis. Now, notice that this point right here has an x and a y value, just like when you usually graph. Now, the x value comes from this distance here, so the value of this number, and the y comes from this distance here on the y-axis, so the number here. Now, if we're looking at the triangle, the horizontal is going to be our x, and the vertical is going to be our y. Now, the values of sine, cosine, tangent on the graph depend on the x and the y. So for example, in quadrant 1, you have a positive x and a positive y. Now in quadrant 2, notice that we now have a negative x and a positive y. In quadrant 3, both the x and the y are negative, and in quadrant 4, the x's are positive and the y's are negative. So there's a way to remember what is going to be positive or negative. So all students take calculus. I'm going to do that again. Going counterclockwise. A is for all, S is for students, T is for take, and C is for calculus. Now that represents that all sine, cosine, tangent are positive in quadrant 1. Sine is the only thing that's positive in quadrant 1. That means tangent and cosine will be negative. Tangent here in quadrant 3 will be the only thing that's positive. Cosine and sine will be negative. And cosine is the only thing positive in quadrant 4. Cosine is positive, sine is negative, and tangent is negative. Now, if we look at our three triangles that we discussed earlier, we notice that in the unit circle, we have a hypotenuse on our triangle, which is 1. That does alter the legs on these triangles. So across the street from our 30, we have a 1/2. Next to 30 is root 3 over 2, which is across the street from our 60-degree angle. In our 45-degree triangle, we have two congruent sides, as we have an isosceles triangle, which is root 2 divided by 2, root 2 divided by 2. And in our 60, across the street from 60 is root 3 halves. Next to 60, or across the street from 30 degrees, here, down here, is 1/2 with our hypotenuse of 1. So the x is representing the horizontal, which is root 3 over 2. The y is represented by the vertical. So this is your x, this is your y. This is your x, this is your y. And this is your x, and this is your y. I'm going to write these down here. So if we're looking at our specific values, so like sine of theta, cosine of theta, tangent of theta, the sine and the cosine are a little bit easier to see on our special right triangles with the hypotenuse of 1. So for example, sine we know is opposite over hypotenuse. So if we go sine of 30, we want the opposite, which is 1/2, over hypotenuse, which is 1. So that means 1/2 divided by 1, which is 1/2. So sine of 30 degrees is 1/2. Now, cosine of 30 degrees is adjacent. So our adjacent is root 3 over 2, which is divided by 1, which is the hypotenuse, which is just root 3 over 2. Now notice, sine of 30 degrees is 1/2. So 1/2 is your sine of 30 degrees. Cosine of 30 is root 3 over 2. So cosine of 30 is your x value. And you'll notice that pattern that your x corresponds to, this should be theta. Your x corresponds to the cosine and your y corresponds to your sine. So cosine, sine. The way that I remember it is, I think, alphabet. If you sing the alphabet, you have A, B, C, D, F, G, H, I, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y. So in the alphabet, X comes before Y, and in the alphabet, C is before S. So since X is before Y, C is before S, X goes to C, so X values are our cosine, Y values are our sine. So if we look at sine of 45, I'm looking at our y value, that is root 2 over 2. If we go to cosine of 45, we have root 2 over 2. Now 60, sine of 60, root 3 over, that should not be a y, that should be a 2. And cosine, which is 1/2. Now again, these values work because on the unit circle, for these triangles, we have a hypotenuse of 1. Now what is the Pythagorean identity? So Pythagorean identity comes from, which is this here in red, comes from our triangle. So let's draw a triangle, a right triangle, and let's say this is C, A, and B. So with a right triangle, we have something that's called the Pythagorean theorem. So Pythagorean theorem says a squared plus b squared equals c squared. So if we have a special right triangle, we have the hypotenuse is 1. We have, let's call this a 45-degree triangle. So we have root 2 over 2, and we have root 2 over 2. So if we were to plug this in and say root 2 over 2 squared plus root 2 over 2 squared, that's equal to 1 squared. And because our hypotenuse for all of the special triangles are 1, it follows the pattern. Remember this right here? Let's show you one more time. This x value was your cosine value. So this is your cosine of theta. And this right here, this y is your sine of theta. So this is your cosine of theta, sine of theta. So cosine of theta, sine of theta, cosine of theta, sine of theta. And so same here, this is your cosine of theta, this is your sine of theta. So this is where you have sine squared, cosine squared. Sine squared, cosine squared equals that hypotenuse 1. Anything that's squared, 1 squared is 1, so we leave it. Now, we did learn a different method in our class to solve for the angle measures, so I will review that later. This is a different way to use the identity to solve for another trig function. So for example, if you are given a value and you want to find the value of sine of theta, then you would rearrange this and have sine of theta equal to the positive or negative square root of 1 minus cosine squared of theta. Now, it's not theta that's squared, it's the actual function that's squared. So we put the 2 onto cosine, not onto the theta. Same thing if we want to solve for cosine, we rearrange this to have the value of plus or minus square root of 1 minus sine squared of theta. So let's do an example. Given that sine of theta is 0.766, where 0 is less than theta is less than pi halves. Now, what this information is asking you is, what quadrant is your theta in? Well, if theta is between 0 and pi halves, this right here is the quadrant 1 that your theta is in. That will determine if your answer is then going to be positive or if your answer is going to be negative. So since we know that sine of theta is 0.766, we're going to use the identity. So step 1, write the identity. Step 2, take the value that's given. Notice this is not squared, this is just regular, and you're going to put that into for the value of sine. Now, sine in the Pythagorean identity is squared, so I'm going to have to square this value. So in my calculator, I'm going to type in 0.766 squared. And that gives me a really long decimal. That's okay. Just write out the decimal. Do not round. Rounding comes later at the end. I'm going to subtract both sides. Here's my dotted line to help me account for the two sides of the equation. In my calculator, this is what I'm going to do. I'm going to leave this here. I'm not going to touch it. I'm going to go 1 minus, and I'm going to press this second key, and I'm going to press this negative down at the bottom. What that does is it brings the decimal that I just had without me typing it. I'm going to press enter. So I have cosine squared of theta is equal to 0.766 4, 1, 3, 2, 4, 4. I'm going to take the square root of both sides. Now, this is really important to remember that when you take the square root, you have to add that plus or minus. So we have cosine of theta is equal to, and I'm going to, again, not touch this decimal. I'm going to press second, and I'm going to do the square root. I'm going to press second, and I'm going to press that negative to get that answer back in. So I have 0.64284. I'm going to add that plus or minus. Don't forget that plus or minus. And I'm actually going to round to 2 decimal places. I'm going to have plus or minus 0.64. Now, you can only have one answer. And that one answer depends on the quadrant that it lies in. So because theta is in quadrant 1, let's go back to what we were talking about, that all students take calculus. So that means sine of theta is positive, cosine of theta is positive, and tangent of theta is positive. This is all students take calculus. So because we are in quadrant 1, that means your cosine of theta has to be positive. So we have 2 possible answers. We can either have a positive 0.64 or we can have a negative 0.64. Because we have quadrant 1, this negative cannot happen, and we have a positive value for cosine. All right, let's do another example. Given that cosine of theta is equal to negative 0.994, where we have theta between pi halves and pi, find sine, and then also what its tangent. So let's go ahead and set this up. Write out your identity. So sine of theta squared plus cosine of theta squared, that's equal to 1. Which one did they give us? They give us cosine. Notice cosine is not squared, so we're going to square that value when we plug it in. So I have negative 0.994. I'm going to type that into my calculator. So I have parenthesis negative 0.994. Make sure you have parentheses when you're typing in that negative. We're going to square that value, so it comes out to 0.988036 equal to 1. We're adding a sine squared to that. I'm going to subtract that value. Both sides dotted line so I don't forget where my equals is. And again, on my calculator, what I'm going to do is I'm going to press 1 minus, second, press this negative button for the decimal to be carried over. So I have 0.011964 equal to sine squared of theta. I'm going to take the square root of both sides. Again, plus or minus when you take the square root. So again, I'm going to press second for the square root, and I'm going to press second again in this negative button to bring over that decimal. So I have 0.1093, so I'm going to leave it at 1.09. Now again, that means we have 2 possible answers. We have sine of theta equal to positive 0.109 or sine of theta equal to a negative 0.109. Now again, that depends on which quadrant we are in. So which quadrant are we in exactly? Well, if we are between pi halves and pi, that means we are in quadrant 2. Now quadrant 2, let's think about it here. All students take calculus. So that means sine of theta is positive, cosine of theta is negative, and tangent of theta is also negative. So because we are working with sine of theta is positive in quadrant 2. So that means we are not working with the negative, we are working with the positive version of that. Now it's also asking you what is tangent. Well, tangent, I'm going to see if I have some space here. Tangent of theta is equal to sine of theta over cosine of theta. Now that you have sine of theta and you have cosine of theta, you can plug those values in. Oops, that's cosine. Let's write sine first before, so I don't run out of space. We have sine of theta, which is 0.109, divided by cosine, which is negative 0.994. Type that into the calculator. So tangent of theta is 0.109 divided by negative 0.994. So tangent of theta is equal to a negative 0.1096. So I'm going to round to, this has to go to 0, so 1, 1. Oops, it should be a 1, 1, not a 1, 2. And that is your answer for tangent. All right, so let's talk about yet another identity. So another identity is your tangent of theta, which is equal to sine over cosine. We did just use that here in the previous example. So because you have this other identity, you can rearrange it. So for example, you can take cosine and multiply cosine on both sides, which ends up being cosine of theta times tangent of theta, which is equal to sine of theta. And if you square all of it, square both sides, then you can get cosine squared of theta. Tangent squared of theta is equal to sine squared of theta. Now, I do want to point out there is another way of solving it, the previous example that we just did. Now, the previous method that we learned is we learned inverse functions. So if we had cosine of theta and we wanted to solve for theta, now it's not what it's asking us. It's asking us to solve for sine of theta. But if we knew theta, perhaps we can plug it into the calculator. So what I'm going to do is I'm going to use the inverse function to solve for the angle. So if we have cosine of theta is equal to negative 0.994, I'm going to take the inverse of that and get my theta. Now, the good thing about this is that we can use our calculator. So inverse of cosine, 0.99, oops, negative, almost forgot that's going to change this a lot. I'm going to press enter, and that means theta is equal to about 173.72 degrees. Now, again, that's not what it's asking us. So I'm going to then take sine of theta, which is 173.72-ish degrees, and I'm going to plug that into the calculator. So we have sine of 173.72. Press enter, and we have 0.109. Now, if we look here, so then we can say sine of theta is equal to 0.109. And if we go back to our example, we'll notice that, in fact, it is that positive 0.109. So the important thing is make sure you're reading the directions. If they are asking you to use the Pythagorean identity, you have to do it this way. If they are just asking you to solve for sine of theta, then you can use any method you like. And if you choose to use inverses, you can. All right, beautiful people. Thank you so much for watching, and I'll see you next time. Bye.